Good morning, students. Our today's topic in the subject of physics is heat capacity and specific heat capacity. This is easy subject somewhat. So even then, concentrate yourself. We are going to start. Heat capacity. The heat capacity is represented by capital C of an object is defined as the amount of the heat required to raise the temperature of the object by 1 Kelvin or 1 degree C. The SI unit of the heat capacity capital C is joule per Kelvin or joule per degree C. So these are two units, and the definition is the amount of heat required to raise the temperature of the body by 1 Kelvin or 1 degree C. Mathematically, the heat capacity capital C is expressed as follows. Capital C is equal to Q over delta theta, where Q is the heat absorbed or released in joule, whereas delta theta change in temperature in degree K or degree C. So therefore Q, so leave Q here, delta theta will be multiplied by C, so Q is equal to C delta theta. So this is an other alternate form of original formula. So this is the original formula, this is the alternate form. Now we are going to do a question. When a piece of the iron is cooled from 70 degree to 40 degree, so look now, delta theta is actually the change in temperature. So the change in temperature is 30 degree, that will be placed in place of the delta theta. The heat given out is 690 joule, that is Q, and the requirement is what is the heat capacity of the piece of the iron. So look now, formula is Q is equal to C delta theta. Q is 690 joule and over delta theta is 30 degree. So when you will solve it on the calculator, you will get the answer. This is wrongly like this formula is written. You can write this formula directly. Okay, next question which we are going to do is in a simple experiment, 100 grams of the water requires 12,600 joule of the heat. So this is the Q to raise its temperature from 30 degree to 60 degree. So change in temperature is 30 degree. Find the heat capacity of 100 grams of the water. So 100 grams is given and the same amount of the water heat capacity is the requirement. So Q is equal to C delta theta and C will be equal to Q over delta theta. So Q is 12,600 and delta theta is 30 to 60. So 30 degree will be the change. So 30 will be put in the denominator, solve it on the calculator, you will get the answer. Unit will be joule per degree C because energy is in joule and temperature is in degree C. B part is find the heat capacity of 1000 grams of the water. So all the remaining things are same, only the quantity of the water is increased, that is actually the 10 times of A part. So we will directly multiply 10 with the answer of the heat capacity. So look now, 10 into 420 will be 4200 joule per degree C. Okay, in C part, find the heat needed to raise 1000 grams of the water from 30 degrees C to 40 degrees C. So for 1000 grams, the heat capacity is now 42,000 joule, which we have, 4200 joule that we have find in B part, that will be used, and the temperature change is 10 degree. And the heat needed is the requirement. So Q is equal to C delta theta will be the formula that will be used. C is 4200, that is that we have find in B part, that will be placed in place of C, and delta theta is 10 degree. So 10 will be placed, you will get the answer, and that will have an unit of joule. Okay, next topic in the lecture is specific heat capacity. The specific heat capacity of a substance is the heat required to produce 1 degree C rise in 1 kilogram. So if you look closely at the definition, only the mass is the difference. 1 kg mass is now given. In heat capacity, it was the definition was the energy needed to require the raise the temperature of any body by 1 degree C or 1 degree K. But in specific heat capacity, this is the change only, that is 1 kg. We will not write any body, we will write 1 kg body. So look now, the specific heat capacity of a substance is the heat required to produce a 1 degree rise in 1 kg. So this is the definition. Heat, like other forms of the energy, is measured in joule, and the unit of the specific heat capacity is the joule per kilogram. So this is the difference now. The unit of the heat capacity was joule per degree C, but the unit of the specific heat capacity is joule per kg degree C. So this is the difference. In definition, 1 kg is the difference, and in a unit, kilogram is the difference. The heat equation. Heat received or given out. The formula is mass multiplied by specific heat capacity multiplied by temperature change. So mass is represented by m, heat capacity is represented by small c, and temperature change is represented by delta theta. So the equation is Q is equal to mc delta theta. So this is the equation. For example, if the temperature of a 5 kilogram mass of the copper of specific heat capacity 400 joule per kg degree C rises from 15 degree to 25 degree C, the heat received will be, look here now, 15 to 25, 10 degree will be delta theta. This is the specific heat capacity, that is 400 joule per kg degree C is given, and the mass is 5 kg given. So formula is Q is equal to mc delta theta. So now values are going to be placed. Mass is 5 kg, C is 400, and delta theta is 10. So values are put. So now solve it on the calculator. You will get the answer 20,000 because this is energy. So unit will be joule. Mathematically, the relation between small c and capital C is C is equal to small c is equal to capital C over small m. So 1 over m will remain as it is, and this capital C is equal to Q over delta theta. So we have put the value of capital C here. So from here, Q will remain here, and m and delta theta, which are in denominator, will come to left side. So the formula will become Q is equal to mc delta theta. Note, it is important to know the differences between capital C and small c. Heat capacity, capital C, is dependent on mass, whereas specific heat capacity, small c, is for unit mass, because in definition 1 kg was given. Thus capital C and small c have different units, because capital C's unit was joule per degree C, and small c unit is joule per kg degree C. So this is the difference in units. However, both capital C and small c are affected by the type of the material. Okay, now we are going to read some practical work. Finding specific heat capacities. You need to know the power of the 12-watt electrical immersion heater to be used. Note, do not use one with a cracked seal. A 40-watt heater converts 40 joule of the electrical energy into heat energy per second. So this is the concept. This is the key point about 40-watt heater. A 40-watt heater converts 40 joule of the electrical energy into heat energy per second. If the power is not marked on the heater, ask about it. So now we are going to read the water. So concentrate now. The heat capacity of the water. Weigh out 1 kg of the water into a container, for example, an aluminium saucepan. So this is the setup. We will weigh 1 kg of the water and put it into the aluminium pan. Note the temperature of the water, insert the heater. So we will note the initial temperature of the water with the help of the thermometer like this. Figure below and switch on the 12-volt supply. So after noting the initial temperature, we will switch on the 12-volt supply. Stir the water and after 5 minutes switch off. So while heating the water, we will keep on stirring the water so that the heat is distributed uniformly. And after 5 minutes, switch off the supply. But continue stirring and note the highest temperature reached. And in this during process, in the process of 5 minutes, we will note the highest temperature reached on the thermometer. Assuming that the heat supplied by the heater equals the heat received by the water, that we are supposing that no heat is lost to the environment. The full heat that is supplied by the heater is received by the water. Work out the specific heat capacity of the water in joule per kg degree C as shown below. So look now. Heat received by water. Heat received by the water is equal to PT. It means Q is equal to PT. But Q is equal to MC delta theta, in which C is the specific heat capacity. So leaving C here, M and delta theta will go to the denominator of the right side. So M and delta theta is in denominator, and here is heat received by the water. So this is the equation. Okay, now the next practical work is, now we are going to find the specific heat capacity of aluminium. A cylinder weighing 1 kg and having 2 holes drilled in it is used. So one hole will be drilled in the middle and second at the border of the container. So a cylinder that whose mass is 1 kg will be taken and 2 holes will be drilled. Place the immersion heater in the central hole and a thermometer in the other hole like this. Figure below. Note the temperature. Okay, first initial temperature will be noted through this thermometer. After that, connect the heater to a 12-volt supply and switch it for 5 minutes. When the temperature stops rising, record its highest value. So, like the previous experiment, we will note the highest temperature during 5-minute process. Calculate the specific heat capacity as before. So now the again same procedure of finding the specific heat capacity as we have used in water will be used for aluminium as well. Okay, next topic which we are going to read in the lecture is importance of high specific heat capacity of the water. As you people know, the specific heat capacity of the water is 4200. That is too high. So what is the importance? So we are going to read. This is very important short question as far as your paper is concerned. The specific heat capacity of water is 4200 joule per kg degree C, and that of soil is about 800 joule. So look at the difference. Soil's heat capacity is 800 and of water is 4200. That is almost 5 times. So look now, as a result, the temperature of the sea rises and falls more slowly than that of the land. A certain mass of the water needs 5 times more heat than the same mass of the soil for its temperature to rise by 1 degree C. So look at the reason. So it requires, if we are given 1 kg of water and 1 kg of the soil. Whatever the energy that is required for the soil to raise the temperature by 1 degree C, the water will took 5 times of the energy as that of the soil. Water also has to give out more heat to fall 1 degree C. Since islands are surrounded by water, they experience much smaller changes of the temperature from summer to winter than large land masses such as Central Asia. The coastal areas and islands keep cooler in summer and warmer in winter compared to inland areas. So this is the importance of the high specific heat capacity of water. The high. So here we are going to read some more importance of the high specific heat capacity of water. The high specific heat capacity of water, as well as its cheapness and availability, accounts for its use to cool car engines and in the radiators of the central heating system. So this is the reason water is used in these things. Another common application is the use of the hot water bottles to keep warm. Okay, now we are going to read some worked examples of specific heat capacity. So look now, a tank holding 60 kg of water is heated by 3 kilowatt electric immersion heater. If the specific heat capacity of water is 4200 joule per kg degree C, estimate the time for the temperature to rise from 10 degrees C to 60 degrees C. Okay, heat absorbed by water will be equal to heat supplied by heater. Okay, heat supplied by water formula is mc delta theta, and heat supplied by heater formula is Q is equal to PT. So this is the formula. Now we are going to put the values in it, and because time is the requirement, T will remain here and P will come to the denominator of this vector. So M is given 60, C is given 4200, delta theta is 50 degree, so 50 will be there, and over P, that is given 3 kilowatt. So standard unit is watt, so this 3 kilowatt will be converted to watt, so 3000 will be placed here. Solve it on the calculator. Answer is 4200 seconds, because second unit will be there, but this is a big value, so we will convert it into minutes by dividing this value by 60. So 70 minutes is the answer. Another question is here. An electric heating coil supplies 50 watt of the power to a metal block of the mass 0.60 kg and raises the temperature of the block from 20 degrees C to 45 degrees C in 90 seconds. Calculate the specific heat capacity of the metal. So look now, heat absorbed by block will be equal to heat supplied by heating coil. Heat absorbed by the block, mc delta theta, will be equal to PT. Okay, now specific heat capacity is the requirement, so this C will remain here, M and delta theta will go to the denominator of PT. So now this P is given, that is 50 watt, time is given, that is 90 seconds, then M is, mass is 0.60, and the temperature change delta theta is 20 to 45 will be 25. So values are put. Now solve it on the calculator, you will get the answer, because this is specific heat capacity. Unit will be joule per kg degree C. Another question is here. A piece of the aluminium of mass 0.5 kg is heated to 100 degrees C and then placed in 0.4 kg of water at 10 degrees C. if the resulting temperature of the mixture is 30 degrees C. What is the specific heat capacity of aluminium if that of water is 4200 joule per kg degrees C? Okay, for the water, heat absorbed by water, formula is mc delta theta. So m for the water is 0.4, C is 4200, and the initial temperature of the water was 10 and the final temperature was 30 degrees. So change in temperature was 20. So 20 will be placed in place of delta theta. Now for aluminium, the mass is 0.5. C is the requirement for the aluminium, and the temperature change is from 100 degree to 30 degrees. So 70 will be placed here. Now from here C will be find out and the unit will be joule per kg degrees C. The next question is 0.5 kg of the orange squash at 30 degrees C is placed in a refrigerator which can remove heat at an average rate of 20 joule per second. How long will it take to cool the orange squash to 5 degrees C? The specific heat capacity of the orange squash is 4200 joule per kg degrees C. So the heat removed by the refrigerator will be equal to heat lost by the orange squash. So Pt is equal to mc delta theta, and P will be shifted to right hand side. So P is 20 joule per second. M for the juice is 0.5 is the mass. C is 4200. Delta theta is from 30 to 5. So difference will be 25. So solve it on the calculator. Answer will be this, and unit for time will be second. Again, this is a bigger value. So we will convert this value to minutes by dividing the value by 60. So 43.8 minutes will be the time in which 0.5 kg of the orange squash will be cooled from 30 to 5 degrees C. So students, this was the lecture. Interesting one, easy one, but technical one and important one also. So read this lecture again carefully, understand it, learn it, make your notes. Thank you so much.